In this video, we're going to talk about the last function operation, the composition of two functions, which is basically just plugging one function into another. The composition of the function f with the function g is written like f of g of x. So the way you actually read that is f of g of x. And what's going on is, normally, you would plug in your inputs here in the parentheses, and normally, right, it's f of x, and the input is just an x. Well, here we're not inputting just x, we're actually plugging in another function, g of x. And so that's what a composition is. You plug one function in as an input for another function. When you find the domain for a composition f of g of x, you always want to start with these these three steps. It's probably the easiest thing to do. We're going to find the domain first of the inner function, which is g of x. That's what you're just plugging into the other function. So I call this the inner function. So this is our inner, oops, don't want to write that letter. I want to write the inner function. And then you're going to find the domain of the final composition. So whatever f of g of x equals, you're going to look at that domain. And then similar to what we did for adding, subtracting, multiplying, and dividing, we're just going to use then the domain that works for both. And so here's an example. We're actually going to do a few examples. So in example 2 it says, perform the operation and state the domain if we have f of x be 2 root x and g of x be x squared. For part A, we're going to do f of g of x. So this is what I recommend you do until you get the hang of it. I'm going to write f of g of x as f of g of x. Now note, first of all, that this is our inner function. It's g of x. And what I'm going to do is, I am going to rewrite the function f, the outer function. So when I refer to the outer function, the letter that's on the very outside, that's your outer function, okay? So when I first do these, I like to rewrite the outer function, which in this case is f, with, instead of an x, a box. So what I'm going to do is, instead of writing 2 square root of x, I'm going to put 2 square root of box. So if you want to write this down, it may not be a bad idea, and then you can look at it later on when you get stuck in a different problem. But the first thing I always do is I rewrite the outer function with, and I'm going to call it an input box rather than an x. So I'm just going to say instead of an x. That's going to leave us room then to plug in g of x in that function. So remember, this is what we're plugging in over here. We're plugging in g of x. So that's what's going to go in the input box. Really, I want to plug g of x in. Well, the good news is they do tell us what g of x equals. Over here they're saying it's just the expression x squared. It's the function for squaring. So what I can do then is I can say, alright, well, f of g of x is really just going to be 2 times the square root of, and remember, g of x is really the function x squared. So that's what we have. We have 2 square root of x squared. Now, sometimes you can simplify, sometimes you cannot. In this case, the square root of x squared, you should know, is just x. So I get 2x. So my final answer here is f of g of x is just 2 times x. Now, what I want to do is figure out what is the domain for this final function. There's a 3-step process similar to what we did before. The first step is to find the domain of the inner function. Okay? And this is all, of course, this is written right up here in those 3 steps. So we're going to find the domain of the inner function, which in this particular example, the inner function is g of x, right? Well, g of x is x squared. So g of x equals x squared. Do we have any domain issues? I don't think so. This is not an even root. We're squaring, and there's not any x values in the denominator. So I could plug in any x value that I please into x squared. So I would say that this is all reals. There is no restriction on this domain. Step 2. We're going to find the domain of the final composition. So we're going to look at f of g of x. Okay, so our final answer, which was 2x, and when you look at that, f of g of x doesn't have any domain issues either. There is no even root. There's no x values in the denominator. It's just you tell me a number and I multiply it by 2. That's all 2x does. So I would say again, this is all reals. Now, step 3 is to put these together and use the most restrictive domain. But since they're both all reals, your final answer for this domain, so you would say the domain is all real, since there was no restriction on either of the prior two steps. So let's do another couple of examples here. Part B is g of f of x. Well, to do g of f of x, keep in mind g is now the outer function and f of x is the inner functions. We're gonna plug f of x inside of the function g. So I'm going to rewrite the outer function within input box rather than an x. So I'm going to put box squared instead of x squared. Right? I'm rewriting the outer function this time. Now in that outer function will go f of x. That's what we're inputting. So I can rewrite that as 2 square root of x. Now the input box kind of works as parentheses. I need to square that entire function. Right? I replaced f of x with what it is. It's 2 times the square root of x. So we just need to simplify. Since I have a product to a power, I can distribute that power to the 2 and have it as 4. And then if you square the square root of x, you would just get x. So in this example, g of f of x is just 4x. So now we have to find the domain. First step, find the domain of the inner function. So I'm going to do domain of the inner function. Now the inner function was f of x, right? And f of x does have a domain issue. I got a square root. That's an even root right there. So we have a problem. I have to make sure that my radicand x is bigger than or equal to 0. I don't want to plug in a negative because then it will be an imaginary output. Step 2, we're going to do the domain of the final answer. Now the final answer, remember we had g of f of x is just 4x. And there is no domain issue with 4 times a number, right? You can plug in any number and multiply it by 4 and no big deal. So this would be all reals. Alright, now third and final step is to put all of that together. If you take into account that for step 1 we have to pick x values that are non-negative or bigger than or equal to 0, and then step 2 is just all reals, you have to pick the most restrictive and say, alright, my final domain is going to be all x values bigger than or equal to 0. And that's kind of tricky because when a student sees their final answer for their g of f of x, they see 4x, and if you only were to look at 4x, you would say, well, I can plug in anything. What you don't realize, though, is that 4x was generated really from this composition where our original input was 2 square root of x. And if you were to plug in a negative at this stage in the game, we would have an imaginary output, and there would be no output for g of f of x. That's why I recommend that we go through all 3 of these steps and not just look at your final answer. Let's do another couple. I think you'll get the hang of it. This time we're doing f of x. Very, very bizarre if you think about it. We're plugging a function into itself, right? So I'm going to do f of x and use an input box to root input box. And we're going to plug in f of x right away. Now if you're kind of getting the hang of it, rather than write f of x inside, I'm just going to go ahead and write 2 root x. Okay, so we plugged in f of x inside of itself, and I get 2 square root of 2 square root of x. Now, We don't want to have radicals inside of radicals, and that just looks really complicated and scary looking. But if we rewrite this with a rational exponent, I think we can simplify. So I can rewrite this as 2, and instead of this this outer radical, I can write like this whole thing's being raised to the half power. And inside, I have 2 square root of x, which I can write as 2x to the 1/2. Now I can distribute the half power, and I'd rewrite this 2, and it would be times 2 to the 1/2, and then 1/2 times 1/2 would be x to the 1/4 power. So if I were to do one more property here, if I'm multiplying like bases, remember we add exponents, so I can do 1 plus a half, which would be 3 over 2, so I'd get 2 to the 3 over 2 power x to the 1/4. This would be f of x. So our final answer here is a little bit more complicated, right? A little bit harder to simplify. Our steps would be very much the same for finding the domain. First, the domain of f of x, which is our inner function, right? And that was 2 root x. This has the same exact domain that we did in the last example. It would be bigger than or equal to 0. Step 2 is the domain of the final function f of x, which, if you think about it, that was 2 to the 3/2 x to the 1/4. Do we have a domain issue? Absolutely. Look at that. There's a 4 in the denominator to that exponent for x. That's an even root. So once again, I have to make sure that the base of that is going to be non-negative. So I'm going to say, all right, x is bigger than or equal to 0. If you put all that together for step 3, I'm just going to squeeze it down here. The domain that works for both 1 and 2 is going to be all x values bigger than or equal to 0. So this would be your final domain for part C. Let's do G, kind of separate this out over here. G of x. I'm just going to go ahead and not copy that down. G of x. So I'm going to rewrite the outer function g with a box instead of x. So box squared. Oops, let me get rid of that circle job so we can do this. There we go. So I have box squared. Now inside the box, I'm going to plug in x squared. So really I have x squared squared. Well, you know the properties of exponents here. We have a power of a power. We're going to multiply, so we get x to the 4th. This was not nearly as tough as f of x, so we got g of x is just x to the 4th. As far as the domain, first step, let's find the domain of the inner function, which is g of x, and that was x squared. Remember, this is not an even root. We're just squaring. That is not an issue. We can square anything, so the domain is all real so far. Step 2, the domain of the final answer, which would just be looking at what, x to the 4th, right? That was our final answer for g of x. That is also not an even root. We're just raising something to the 4th. We can do that with any number. Give me a positive or a negative or anything you'd like, and I can raise it to the 4th power. So that's all reals. And what works for both? Well, obviously all reals would then be your domain for this guy. Let's do another set of examples. This can be pretty tricky. And then we'll leave you with some to try on your own. So here in example 3, it says let f of x be 2x to the negative 1 and g of x be x minus 1. Keep in mind the following. I'm always leery. The book will try to trick you, and even I will try to trick you. Sometimes we'll give you functions with negative exponents. Keep in mind that is exactly the same as saying f of x equals 2 over x to the positive 1. Right? Now notice the 2 didn't go downstairs, only the x did, because 2 is not being raised to the negative first. Only the x is. So this is another way of thinking of f of x. Alright, let's look at A. Let's do f of g of x. If it's okay with you, I'm going to save a little bit of time and just rewrite f, the outer function, with the box. So it'll be 2 box to the negative first. Right? And in that box goes x minus 1. So really what we have here is 2 times the quantity x minus 1 raised to the negative first. Well, I always hate negative exponents, so I'm going to move this downstairs as 2 over x minus 1. So this is f of g of x, and we're done, except for, I think we also have to state the domain. So let's go through the steps. Step 1, the domain of the inner function, which would be g of x, and g of x is just x minus 1. No problem there, that's just a linear equation. Take a number and subtract 1. So this is all reals. Step 2, the domain of the final answer, which was 2 over x minus 1. Is there a domain issue? Absolutely. I have an x value in the denominator right there, so I have to be careful to not let that x minus 1 equal 0. And if I solve that, that would mean x would be 1. This is the only value that I should not plug in, because if I plugged in a 1, I'd get 1 minus 1 in the denominator, and it would become 0, and therefore undefined. So I would say, okay, all but don't let x be equal to 1. Step 3, what works for both? All reals and all reals but x can't be 1. Well, you're going to use the most restrictive. You just don't want to use 1, and anything else is okay. So final answer for domain would be all but x should not equal 1. And that even is kind of obvious. If you look at the final composition there, you wouldn't want to plug in 1 in the denominator. You'd get a 0. Let's take a look at b. If I do b, now the outer function is g. So if I rewrite g with a box, it's box minus 1, right? Take your input, take away 1. That's what g of x does. In there, we're plugging in f of x. So I can write it two ways. I can do 2x and negative 1, or if you wanted to use this alternate notation right away, it's probably not a bad idea. In the box, you could have just went right to 2 over x. And if you have 2 over x minus 1, you're done, guys. There's no common denominator here. There's nothing to simplify. So this would be your final answer for g. Let me erase this a little bit so I have room. So your final answer for g of f of x is just 2 over x take away 1. Alright, the domain. Step 1, the domain of the inner, which in this case is f. And f of x was, and you know what? Let's write it like this, because it's a little bit more obvious that there's a domain issue. Remember, f of x is 2 over x really. And there is a domain issue. I have an x value in the denominator, and therefore I do not want x to be equal to 0. So far I know I can use anything besides 0 for my domain. Step 2, if you look at the domain of the final answer, which was 2 over x take away 1, we still have a domain issue. We still have an x value in the denominator, and what will make that 0 is still x is 0. So we still don't want to use 0. So if you put those together, they're speaking the same language. They're both saying use any number you'd like, but just don't please plug in 0, because I won't be able to divide by 0. So all but you should not let x be equal to 0 would be your domain. Let's do a couple last ones. F of x. So in this case, f of x, we're going to write it as 2 over box, right? If I use that alternate notation. And in the input box is going to be 2 over x. Now, in this problem, if we use this notation, really we're getting into something that we didn't learn. This is technically an algebra 1 thing, but when you have a fraction within a fraction, we have a complex fraction, and we would want to simplify that. So I'll just show you. I guess it's really not that hard. Think about it, guys. In the top we have 2, and what we want to do is divide that 2 by this, 2 over x. Well, you guys know that division is the same as multiplication with the reciprocal. So I can multiply it by the reciprocal, which is x over 2. Well, this works out nicely because 2 times x over 1 times 2 is 2x over 2, and the 2's cancel. So you really just get x out of this thing. Okay, so at the end of the day, f of x is just x. That works out pretty nicely. Step 1, the domain of the inner, which remember was 2 over x, that's f of x. we don't want to use 0 because we're dividing by 0. Step 2, the domain of the final. Well, the final answer was just f of x, or f of x is just x, and there's no issue there, so that would be all reals. What works for both is a domain that, the domain that will not use 0, right? We have to take into account, we can't plug in 0, but we could use anything else, so the domain is all but don't let x equal to 0. Last example, and then we'll have you guys try a couple, see how you do. G of x. Okay, so the outer function now is g. I'm going to rewrite that as box, take away 1, and inside we're plugging that same function in, which is just x minus 1. So this is x minus 1 minus 1, x minus 2. Well, that was easy. G of x in this example was just x minus 2 for the domain. Step 1, the domain of the inner is g of x, which is x minus 1, and there is no domain issue here, right? There's no even roots, there's no x values in the bottom, so this is all reals. And if you look at the final answer, the final answer was x minus 2, and there's still not a domain issue, so we're using a domain of all reals. I have all reals, and geez, that's pretty good. So I have a domain of all reals, and then my third step is to use what works for both. Well, all reals and all reals, we're going to just choose all reals for our final domain. So I want you guys to try, if you are so brave, the last example. You're doing f of g of x, g of f of x, f of x, and g of x, and stating the domain for these guys. And this is kind of similar to the last one we did. So hopefully, if you get stuck, you can refer to some of the steps that I did in the last one and see how it goes. Good luck, and we'll talk about it tomorrow.